Hello, everyone. My name is Alexis Haw. I'm a junior at Sage Hill High School. I'm currently a participant in Dr. Wong's lab at UCI, and I'm here today. Please introduce yourself.
My name is Felipe Vasquez. I'm a telecom engineer with a deep interest in business and international experience in four continents, mainly in corporate development of incumbent carriers. After traveling like a fool and suffering the inefficiencies of the hospitality industry on a daily basis, I launched Ameniti, which provides everything from automated omnichannel answers to assisted decision-making based on real-time data analysis.
My background began in real estate development and construction. Philip and I met when we began development of a construction and property management software, which began with him advising us on that. And since then, we've become partners in multiple ventures, pulling our resources in one combination with one another.
And then could you please tell us how you got introduced into the Bridge Ventilator Consortium and what you guys did?
We were introduced to the BBC by Oxygen Protofile. We were one of the first partners of Oxygen, a Barcelona-based collaborative open project, which expanded rapidly and became an essential resource for many developing countries.
Mm-hmm.
Through this project, all members produce ventilators using the same design, and any improvements to that design are shared collectively. Looking at the network today, you can see how successful it has been since it started in March.
And then what's the name of your ventilator?
So we actually produce two different models. One is the acrylic model that you can kind of see here, which has gone through many renditions and is a Ventila LP. And the second is the second generation Ventila Oxygen, which utilizes a metal body and more machine parts.
And then can you just explain a little bit about the fundamental mechanisms of your ventilators?
Sure. Both of the models are powered by a common windshield wiper motor, then typical mechanical fasteners, but the significant difference really is just the bodies themselves. Our ventilators function by using an adjustable cam, which is common to the Protofile model, and then a more simplified model, which we have here, and another metal model actually. We use a piston and an adjustable height table. The cam and piston are used to compress widely available manual resuscitation bags to control tidal volume, the respiratory rate, detect changes in airflow, and alert medical professionals if there's a blockage or restrictions during inspiration-expiration. We use an alarm and a light to signify that.
So it does have like a lot of different components to it, but it does seem very scalable and very simple and affordable. So could you tell us a little bit about like bringing it over to the US and what it was like?
Yeah, so the basis is the Protofile design. We're able to build test units, adapt the CAD files to allow us to use components more widely available in the US. Each individual component was then indexed and then analyzed to find alternative parts that were at a low cost and higher quantities. For instance, nuts and bolts were brought into imperial system sizes, and a suitable airflow sensor was found that's common to many air conditioning systems in the US, and it is very cheap.
Our ventilators, both acrylic and metal, are purely mechanical, and this is because it makes manufacturing very simple. It ensures the integrity of the supply chain and allows us to use easily substitutable components that can be found everywhere. Because of the simplicity of our model and the lack of supply chain problems, our ventilators are incredibly scalable. Both models are affordable as well, with both costing around $700 to produce in mass, with variation mostly due to the shipping cost. Ventila LP or acrylic model can be produced by anyone with a table router in a few hours, with no expertise required. This model is lighter, which keeps transportation costs low. Ventila Oxygen or metal model is meant for industrial production and requires some engineering knowledge to produce. In terms of bringing our model to the US, we had to make several modifications. We adapted the electrical components to the US market. This involves replaced components to work with the US voltage, frequency, and black type standards. After that, the design changed and we had to adapt the CAD for cuts and machining to the needs of the components. We then produced prototypes and performed endurance tests. Time was crucial in the pandemic response. We chose to partner with the project most likely to get medical approval and to replicate the most promising European model that would be ready to produce in mass right away. And this was the best, most secure response for the dramatic situation that was already apparent in Europe. We were lucky to be able to learn from the experience of other countries. After consulting doctors on the ground at the temporary hospital set up at the Jacob-Javits Convention Center in New York City, we learned that the peak of need for ventilators would be April 21st. We started this project on March 22nd, and we were ready to begin producing mass ventilators by the first week of February. The oxygen prototype ventilator was approved for use in hospitals in Spain on April 3rd. For simplicity, scalability, and affordability, meant that we would be ready when we were needed most.
So you were kind of alluding to this earlier, but I saw that the oxygen received approval for the AEMPS for the Spanish Agency Medicine and Health Products, which is like comparable to the FDA in America, to start use in all patients in all hospitals. So that's amazing. So you were manufacturing in Spain, right?
Yep. That's where we began, and then we were able to adapt that same process that they use at the seat manufacturing facility, bring that here, do that in our own private institutions with some of the clients that we had developed within the real estate industry, allowed us to use their space, and began to adapt that to the US.
And then could you talk about what it was like, the process of filing paperwork for the EUA in America and then compared to the one in Spain?
The EUA was a very difficult, time-consuming process. It was tons and tons of paperwork and a real backlog. And the oxygen model design was also used to build the Virgin Orbit model, which was approved by FDA on April 23rd through the BBC. We were able to get some same documentation that Virgin Orbit submitted for the approval, which was essentially helpful, and we were able to use the same design. However, by that time it was too late for ventilators in the US, and the demand had dropped off quite a bit.
Right. And then obviously you guys have been working for some time now, so has the design changed at all?
Yeah, the design has changed quite a bit over time with our always looking for alternative parts and pieces that we can find in higher quantities, and just at a larger rate.
Right, and then you guys kind of touched upon this earlier, but where can we find your ventilators, and then is it available to the public?
Yeah, our ventilators are available to the public, and if you actually go to ventila.com, you can find there, and we're producing on an on-demand and as needed basis.
And then Ameniti right now is like more in the hospitality industry. So what direction does your business plan on going other than the hospitality industry?
As the hospitality industry is suffering right now, we are currently expanding to other industries. Over time, we realized that any business can take advantage of the AI solution we have built. Basically, we can help reduce cost and promote efficiency across all the industry. We are continuing to provide services to hotels, and automation is especially useful in hospitality right now for safety and social distancing reasons. But we are no longer limiting ourselves to a single industry.
And then do you guys have any ongoing projects right now that I could talk about?
As I mentioned, I am a telecom engineer. In July, I began advising the government of Andorra on a new method of contact tracing based on Google and Apple technologies. Our expertise with the usage of both Google and Apple platforms, as well as other technology for Ameniti, made us comfortable to design a secure and private and, most importantly, universal, simple and inexpensive solution to allow tracing of citizens from all countries, even for countries without a tracing app in place. Here, we are solving the universality of tracing. In the US right now, travel is limited between states, and some states have developed their own tracing apps. Mm-hmm. Universal contact tracing solution is essential if we want to return to an interconnected world, instead of worlds that are only connected virtually. This is taking into account that vaccine would be 50% effective as an estimated average. As a hospitality veteran, I believe effective tracing will be one of the factors that restarts international travel, and beyond that, it will help us to get back to the old normal.
Okay. Yeah, that's really good. That's amazing that you guys are doing that. Could you please tell me a little bit what was the biggest challenge that you guys faced during this whole process? Because I'm sure there are many, but which one would you say is the biggest challenge out of all of them?
I mean, obviously, the timeline and coordination was very difficult. And then in the beginning, we've also been involved in virtual work, but making that adaptation right away was difficult, especially when you're talking about creating and supplying all the paperwork that the EUA needs was just a real headache. And
right. Yeah. And then what was the best part?
I think the BBC, the BBC, the way they conducted the meetings, the extent of the subjects they covered, the quality of the professionals involved. The whole experience was the best part.
And then is there anything you would like to add or comment? And then maybe at the end you guys can show, since you have the ventilators in front of us, you could give us a little tour of it.
Sure. Well, talking about COVID on a daily basis is not a happy thing, but the BBC's dedication to this project was a gift and a productive experience, very productive. I wish it could have been under other circumstances for other goals, as I feel that the members will be an asset to any scientific project. But it was an excellent experience and grateful for.
Very.
Very.
So about our ventilators, kind of inside of them, you can see a little bit here. I have it actually plugged in, which is kind of a little bit difficult. Switch it on, and the cam starts moving, which would in turn then push the Amenti back down, provide resuscitation for somebody. It's a little bit loud, but you can actually see the amber light on top and our hose here that connects to the ambu bag and then eventually to the patient. Any airflow that is restricted here sets off our light, and then an alarm that's actually internal to this. We mentioned that airflow sensor is just a typical component found in many HVAC components. Again, a windshield wiper motor powers this, and it can run at variable speeds. So kind of turn it up a little bit here, and then slow it down.
Wow.
Respiration rate.
Yeah.
Just manually set.
And you said that it's been tested on humans and animals before, right?
Yeah, in Spain it was. We've actually run all of our machines for over 75 days continuously with a test and weight on them, and intermediately testing out the sensor so that it doesn't fail as well. And then kind of the basis of where we started was kind of the cheaper, easier to ship option. And this is really something that you could send to someone in the mail in many different pieces. Mm-hmm. It glues together. This one actually was our first test with a piston and the sliding table. So this removes the cam, which kind of makes that louder noise and makes it just a little bit easier to operate and actually last longer because it's a smoother action.
Okay. And then how much is this one compared to the metal body?
So essentially, they're $600-$700, and then shipping the metal one is quite a bit more difficult. Outside of that, the assembly for an individual would be a bit cumbersome.
Mm-hmm. And then it's you guys have videos, right, on how to assemble it and how to use it, so it's very user friendly.
Instruction guides and plans for the entire time.
And then it's also offered in 2 languages, did you say?
Well, we have a video in English and another one in Spanish.
Which makes it very easy for the patients or anyone who's looking to use it. So that's amazing, yeah. All right, thank you so much. Is there anything else you would like to add?
No, just thank you for your time and thank everyone at the BBC.